This is the world's first hydrogen fuel cell based car that ever competed in a motorsport event. We passed scrutineering, all the safety tests, and so we're able to drive in the event and show what the car could do. Our team consists of about 60 students. 40 students are actually designing and building the car, and those students come from all studies like mechanical engineering, electrical engineering, computer engineering, aerospace, and all kinds of studies we have at the university. And also they come from all nationalities. We have people from China, Nepal, Iran, Germany, and of course a lot of students just from the Netherlands. It's really great to see with a project like this how people work together and how motivated they are to build a car, and also to see how people from outside the team like what we're doing and are really enthusiastic about it.
The students have to design, build and race a car against each other in 1 year, and it's actually a bit less than a year because it's within their academic timetable, normally running from about October to June, and it's a really challenging exercise for the students to build a new car every year. They're not allowed to bring along last year's car. Some of our advanced fuel cars running electricity and hydrogen are right at the leading edge of technology. We show people around from big companies and they're really impressed by the level of technology which is ahead of a lot of the major motor manufacturers in terms of fuel cells, electric drives and the developments of internal combustion engines. So it's very challenging for the students, but they get a great experience and employers really value it.
We looked at the car from last year and we decided to not revolutionize it but evolutionize it. So we worked from there, but we looked at every little bit and thought, where could we optimize it, where could we make it better, make it nicer, make it easier to service. So we looked at every little component, and if you look at the end result, it was a revolution instead of an evolution, because we did things totally differently this year. We worked with a lot of good companies like Bürkert to make our whole hydrogen system lighter and smaller and more serviceable. Those are the small details that most people don't see from the outside, but if you look on the inside, you compare it from last year and this year, it's a totally different car.
We went to Bürkert and told them that we needed something where we can measure the pressure, we can measure the temperature, we can control the pressure, and we can measure the mass flow. And we want it all in a box. And then it needed to be as small as possible and as lightweight as possible, because we are making a hydrogen race car, and race cars need to be small and light. So we went to the system house of Bürkert in Germany and talked to the engineers and told them we want something where we can manually close off the high pressure, where we can protect the rest of the system of the high pressure with an overpressure valve. We want to bleed the system when it's needed. We want to know the mass flow of the hydrogen, we want to control the pressure of the hydrogen and measure the pressure and temperature of the hydrogen. So what we have here is the low pressure box, which is custom made by Bürkert especially for us. The hydrogen comes in here from the tank. We can manually close it off if we are working on the rest of the car. We want the high pressure off. And then there is a bleed valve, so we can just bleed the tubes, the hoses when we want to disconnect them. There is an overpressure valve to protect the rest of the system of the high pressure. If we make a mistake at the tank, all the pressure above 50 bars will just go out there. Then we can measure the mass flow, which is on top of here. We can control the pressure in the fuel cell system itself with this component. And then there is a temperature sensor and a pressure sensor. Hydrogen comes out here again and goes to the fuel cell. And when it comes out of the fuel cell, we recirculate it and it's put in back here again. So this is where fresh hydrogen meets with recirculated hydrogen. And so the Bürkert engineers just went to the drawing board, and in about 3 or 4 days they just designed this whole thing, which perfectly met our requirements.
When I started the team 5 years ago, hydrogen technology was even more novel than it is today, even though it is still a very novel thing. And one of the things we found out that specific components in the hydrogen fuel cell were very hard to get by, or they were very big in terms of size and mass. And both of these things are not what you want, not what you're after in a race car. When you're building a normal race car, it suffices to simply get off-the-shelf components sponsored. But if you're like Force acting on the leading edge of technology, these off-the-shelf components simply do not suffice, and therefore you have to really get involved with suppliers, such as in this case Bürkert, to develop new technology. And after all, that is the definition of innovation, not just integrating existing components. That's not progress. Progress is developing those components in the first place. Someone has to do it, and it's nice if universities and industry team up together to do so.